Hello.
Hello, everyone. Hello, Mr. Vitali. So happy to have you here.
Hello, everyone. Can you hear me well?
Hello. Yes, we can hear you well.
Perfect.
Let me see on the chat. Everyone is with us. Okay, people on the chat, are you here? Just type hello. Okay, so welcome everyone to the day 3 of the Udara Lounge training program. We have our guest speaker here, Mr. Vitali. Welcome to the Udara project. We're very happy to have you here. I think we are on time, so we can start with your presentation.
Thank you very much. Uh, Let me share my screen and then I'll just click present. I can share my
Okay.
screen.
Okay.
Let's see entire screen. All right. I think you can see my screen, right? Yep. Are we good?
Yeah. Yeah. We're good.
Perfect. Yeah. Perfect. Right, great to be here. And then I'm very excited to talk about retrieval augmented generation with graphs, and then the open source project I was working on for the past year. And then yeah, I think it will be a good journey. Then we'll talk a lot about um, what is just a graph building process, and also what is like to build an agent that can work on graphs and then answer questions based on this graph retrieval. Okay, a few things about me. So I am a member of technical staff at Anteria, which is a New York-based AI healthcare company. Um, and yeah, we provide AI solutions to health plans, and basically what that means is we work with the cutting edge AI systems. We build AI agents. We work with graphs, and it's not surprising that I'm talking about graphs and AI agents. So I guess to start with, so we need some kind of to lay the ground about what the terminologies are, and then we'll start building on top of it. Yep. So so the idea of basically today's talk is like if we have a code base, can we just convert that into a graph, and uh, and then given that graph, can we use an LLM to retrieve an information we want from the graph and answer user questions, right? So that's the idea. Like, is it worth doing this process, and how much gain we'll get? Basically, going from the code base to the graph and then answering question, and we will compare with the Claude code and see how the differences are when you have this graph process versus just a typical rib grep or grep type of process. Okay. Yeah, just making sure everything is right. Okay. So if okay, um, just bear with me. Okay. Right. Um, so what is retrieval augmented generation? So if we just say in one sentence, RAG is we retrieve a relevant knowledge, we give it to an LLM, and then LLM generates grounded answer based on that retrieved knowledge. Yeah. Today, if we ask an AI model a question without any source provided for it to retrieve, so it will just recall from its memory and it will answer to us. But sometimes we want those answers to be grounded to a source. That's why we give an access to our knowledge base. And then LLM, before answering our question, goes and searches that knowledge base, finds relevant information, and then reads those, and then answers us. That's why it's called grounded answer. Okay. Um, so so that's basically, sometimes you can see even when LLM reads that information, it can also complement that information with its internal knowledge. So, and this is very useful for code, documentation, databases, and knowledge graph when you want to construct this type of retrieval system. So what are the external knowledge? So external knowledge could be code, could be some kind of a database you store information. It can also be a graph. So pretty much doesn't matter the form of a knowledge, as long as AI can access it, retrieve information from them, and then augment its generation. Yeah. So there are different types of retrieval system and similarity search, so-called. What happens when we have embedding only search? And embedding only search, what it means is like when you give a knowledge base, so those are basically encoded as vectors for the AI to search from. And when AI searches specific information, it basically searches in vector space. By vector space, I mean those are basically all our numbers and vectors. So every concept in that knowledge is represented as a vector. So when AI looks at the user question, that's kind of a vector, and looks at what's the similar vector to the user question, and retrieves those, let's say top 10 of those, passes to a memory, and then reads that, and then answers us, right? So, but this similarity search, or this embedding only search, is quite limited, because sometimes just looking at similarity in question and similarity in question and the potential answers is not what we want in some cases. For example, if in vector space, like a building and a garage might be next to each other, which would make sense to kind of retrieve that information if the user is asking about the garage and you retrieve information about a building. But when it comes to domains like code or medical medicine or law, so those kind of fuzzy matching would not work sometimes. That's why you need like more precise matching. And that's why like sometimes this embedding on the limitations do not work. And also that they have some problems with chunking. Depends how you chunk your data, put in a database, and then how you retrieve that. Yeah. So why the structure improves context, and how you can structure your data that could be good for a specific type of retrieval. So graph is one data structure that is really good at preserving relationships in code context. So if you can construct a graph that has call, import, inheritance, all these dependencies, and that would be very useful when LLM retrieves from that graph. It knows those relationship, and there is no heuristic there. Basically, you can just retrieve those relationship deterministically, and then pass that into an LLM for reasoning. So basically, the only bottleneck becomes the AI reasoning instead of a retrieval. So sometimes it can yield a better precision for complex questions, and we can look at the demo, and I will show you what type of questions are better suited for graph RAG. And they are more explainable because the queries return. You can trace it back when you run the same query, you will get the same result. So that's also kind of a benefit of having structured or a graph RAG search. However, in real life, so you don't do one versus the other. So you combine those two things together. And that's why you have similarity plus structure type of context retrieval, which Code Graph RAG repository, the project actually implements. And you can see that this is very powerful. So let's look at some fundamentals on graphs and graph databases, because we're going to use those in Code Graph RAG. So what is a graph? Graph is basically is made of nodes, entity edges or relationships, and properties, which are like key value data. For example, very simple graph is depicted here. When you have a user, which is a node, order, another node, and a product. And the edges between them are those like user, places, order, right? Which means we have a relationship called placed. And we also have key value data, both on a node and on the relationship. In this case, placed is at specific time. And here we have ordered and contains what type of product. And we have contains relationship, and you can have key value pair here as well, like quantity and how many. And the product is another node. Again, the product could be a book or anything, and then it can have it can have some fields in it. So, and the product could be viewed by a user, right? Those could be another relationship. As you can imagine, so this is a very simplified version of a graph, but for a complex entities and the relationship, this can grow really fast, and it would be very hard to navigate and understand which node is related to which related to another node. But there is a structured way to actually query that big graph, and we'll show you how it can be done using Cipher language. And they are, as you can imagine, so those are kind of a data structures that you can keep your data. You can store your data with this data structure. But now the question is how you persist that data in memory. And there are many different graph databases. And one of them is a memgraph. And the reason I'm mentioning memgraph because that's used by Code Graph RAG. And it's an in-memory graph database. It's highly performant. And it has all this, reproducible atomicity and all type of kind of transactions. It supports Cipher query language, and you can actually host it locally with Docker, and you can spin up a container. And it's very easy to spin up and tear down. And it also has a very nice visualization with memgraph lab, which we will gonna play with. It's very easy actually to run it. It's just a one Docker compose command, and you are ready to go. When you are basically have that already running, so you can go and then play with the memgraph lab. And then what you will see, for example, for Code Graph RAG repo, we'll see we can query relationships like defines, imports, inherits, calls, and node types like project, packages, folders, files, classes, and so on. We'll talk more about this. But for now, I just want to show you what it looks like, basically. If you go to now localhost, as you can see, I have already my memgraph container running, and it's being hosted at this port. So if you connect to it, you will see we have this query execution container. That's a different container, by the way. And you can write your Cypher queries here. And the Cypher, we'll talk about a bit Cypher, but it's just similar language to SQL or SQL, where you can declaratively say what you want to retrieve from a database. In this case, it's a graph database. For SQL, it could be a relational database. Also, even non-relational database, they support SQL variants of querying. So it's very similar, as you can see, like match. You're matching something, and you're returning and ordering by, and you can also limit. And it's very, very similar to SQL language. In this case, what we want actually, we want to see, the project, what type of depends on external relationship has, and we want to basically retrieve those external relationships, external packages, and then return their name and version spec, and then we want to order them by name in an alphanumerical ascending order. If we just yeah, so okay, so I guess what this is happening, query failed, order by name, yeah. Okay, I think we're...
Tali, can you hear me?
Yes.
So please, could you, when you're writing code, please could you zoom in, because I can't really see your screen.
Yeah, that's a good point. That's better, right? Yeah, can you see it, or I should zoom in here?
Yeah, it's good. It's good. Yeah, it's good.
Yeah, perfect. So okay, so what as you can see, we have this query failed, and then we'll figure out what the reason is. But for now, I wanted to show you that what the Cypher language looks like, and it has a specific syntax. Always start with a match, and you want to see what type of relationship you are looking for, and yeah, and then you do similar to SQL type of things. Okay. So we have here, if we run, you can see here we have this type of data returned to us. So we have what we have. We have basically want to find in this project all external libraries that have been installed and used. You can see it's a click, I don't know, ESLint, right? Some GitHub repos. And we also have like version specs, and those are we specify here. And then it's nicely returned here in a name graph, basically. If we just omit here, obviously this one, so we'll have only name, right? So that's kind of you can basically return whatever you want. All right. This is okay. So this is about graph databases, and also some demo about a memgraph that is running on a Docker container. And we know, like, you can, if you run this Docker Compose app, you will have this mem graph available to you. You can run it. And also we can run some of the queries here listed, but we'll just defer that for a moment. We're going to run some of them. Okay. So this is about graph and the mem graph. So, but there you can ask, okay, what other types of graphs are available? In this case, there are like this type of two kind of a big family of graphs. I would say that are very famous. One is like a property graph. One is like this RDF triple stores. So you can, as you can imagine, mem graph is like a property graph because it has nodes, relationship, labels, and properties, right? And then everything is visible in a graph. But in a triple store type of a graph, you just put subject, predicate, and object, right? In this case, for example, it's a very easy representation of a graph. You say, what is your subject? What is the predicate in this case call, and what's your object, and that's hash password, right? And basically, you can also see all the relationships if you store this way instead of just directly as nodes and relationships. Um, so our code graph RAG will be using a property graph because our code base contains rich entities, right? We have modules, classes, functions, methods. We would like to see which function calls which function. And you will also some metadata there, like which line is it on. Um, and also relationship matters because we want to have all these relationships, and we can have it extendable. We can add more relationship if you like. And then we can also query via Cypher, and then memgraph is very, you can use Neo4j or any other database. They all support Cypher language and those type of easy to write. And AI agents, they also know Cypher language really well. They can also query on behalf of us if we put in a agentic loop, which we'll see actually in action. Okay. So let's talk now about my project is called Graph RAG, specifically because I just touched on some of the ideas there, right? I mentioned project, I mentioned package, folder, but those are not those names. They have specific meaning in a code graph RAG project, which are basically when you have a project. So this is a graph schema, and you can see it's a very condensed way of representing it. It's almost 100% accurate. Well, there are some details obviously that are hard to bring depict in one picture, but you will get an idea. So when you have a project, so it can have depend on external. You have external packages. The project can contain package, folder, file, or module, and then module can define a class or function, and function can also define nested functions, right? And the class can also define methods. That's why how the class is constructed. And the method can override their method if you have like inheritance. And then a function can call another method can call a function, right? And classes can implement interfaces, and classes can also construct other classes, right? And also, given the specific languages, you might have different type of modules. Like in C++, for example, you can have these exports, module exports, class of function, and or it can just implement a module. So those are basically covered by tree-seated library, which we're going to talk about briefly, and which tries to unify all programming language constructs into one representation when you are converting the code base into a tree, which is in that case it's an abstract syntax tree. But in this case, what we have all the node types, as you can see here, the class function method interface, and there are even more a bit like enum and whatever type, and specific language also nodes. And we also have relationships, and those are mostly universal. We have contains package, contains folder, contains file, contains module, right? Or you have if it defines module,
Hi,
defines the
Vitaly.
functions, and so on. Yep.
Yeah, so again, maybe you could zoom in a bit.
Um,
Yeah,
yes.
and,
Let me
and
let
yeah,
me.
a few people are. I feel like it's a bit too quick for them, so maybe you could just.
Yes, and then I will encourage you to ask questions during the time. So if you have any questions, if anything is unclear, just stop me. Okay.
Okay, you want them to stop you during the talk?
Yes.
Okay, so we're interacting with them via the chat because we're streaming live to YouTube, so that's where the questions are coming.
Excellent. Then we'll have some time at the end then.
Okay, fine then, no
All right.
problem.
Yeah. So I will go a bit slowly then. So the idea of a code graph RAG is, as mentioned before, is like how can we extract these nodes and the relationships between entities that's available in our code base. So and then it's up to us basically to define, okay, what are the nodes and what are the relationships, right? And then it actually took some time for me to figure out that those are the maybe main node types that I care about. That would be very useful to query and find information about them, and those type of relationship that I would like those nodes to have between them. And I would like, for example, to know uh, which class implements which method, right? In that case, I would be interested in defines method relationship. And then when it comes to querying it, I can see all the classes and all methods um, uh, tied to each other, right? And that will be helpful for my understanding of a code base. And don't worry, we'll see the example in action, and that will be more clear. So we have nodes and relationships, and the relationships are basically, as the exhaustive list is here. And again, the relationship uh, could be generic relationship irrespective of a language. In this case, as mentioned, like contains file or module and so on, or a defines relationship, or even the call relationship, which is the most, I guess, one of the most important ones is if you want to know what function or method calls which one. So that's kind of call relationship. There are so many in a code base, and it's easy to trace the lineage of those calls in a graph. But also for object-oriented programming languages, you would like to know like inheritance, implementation, and or overrides, right? If you have like a polymorphism and so on, and those type of relationship is also could be important given the context, what you are looking for, and some specific language things. Okay, if we go. Okay, so if we go to the next one, we already saw the demo of a memgraph, but what I would like to show an example of, let's see, an example of a repository visualized. I have another open source project, and which is called Git CGR. And here with this one, you can actually visualize any GitHub repository instantly, and underneath it is running code graph RAG. And we'll see this in action. If we go to the visualize repositories, you can see people have visualized many repositories, and this is actually free, by the way. And if we choose one of them, let's say this repository, as you can see here, you see the graph visualized, and you can actually see interactively what type of nodes and relationships are available. But also here, you can just basically look at only class and method node types. And this is Microsoft APM package, by the way. If you click on it, that's Microsoft APM package, which is a agentic package manager. I didn't even know about this, by the way. So, and yeah, instead of coming and then looking at the code here, like what it is inside, you can just visualize. The first thing could be just how I visualize this. Try to see some relationship, for example. If I can even choose to see if there's a functional call relationship in them. And here, as you can see, if I just toggle call on and off, you can see there are so many call relationships in this repository. That's very like high level one way of visualizing this. The other way is basically a mem graph where you can just look at a relationship as well. And one way you can do it is if you run a Cypher query, you will see that, for example, if you want to see all the relationships, all caller relationships, so what we can do here, we can just run this. As you can see, and we're returning A and B, but so those are all call relationship that all nodes that have relationships, and we are basically returning all the nodes. Yeah. So the mem graph is very programmatic. You can write and then see any type of relationship here. But if you want a very high level kind of understanding and just see it visually, you can also do that. You can also search here if there is anything about auth, right? As you can see here, I have this test file, which is no auth details and so on, and you can see the relationship between them. You can even export it as a JSON representation of the graph, basically of this code base, which could be useful if you want to use that context somewhere else. Okay. Right. We have that, and so we already looked at Git CGR, which gives you this nice representation, and then node types and relationship you can toggle on and off. You can toggle on and off, right? Yeah, it's very easy to use. I will encourage people to go and check it out. And memgraph, we already played with that. So another thing would be to basically see in a memgraph. In a memgraph, it would be easy to see the relationships. So if we go back, and instead of that, if we run and then see, okay. Oh, there's some weird character here, probably. Okay. Oh, that's the one. Okay. All right. So, and here in the mem graph again, you can see this is, by the way, code graph RAG repository visualized in a mem graph. And here, as you can see, there are like how many nodes they returned and how many edges returned. Yeah, and you can even drill down if you like to see, oh, this is a test. What is this? Is this a folder? This test folder includes so many files, and you can see it's like a peninsula. It's not a complete island because it has one or two connections, right, to the rest of the code base, but it's very very much grouped together into one place because, as you can imagine, test files they live together, right, in a code base. And yeah, so two types of visualization you can try. Okay. Now, if we just now talk about how the graph construction works in a tree-sitter, in using tree-sitter in a code graph RAG, that would make so much more sense how those visualizations are constructed. We are using a library which is called tree-sitter. It's a very well-known library which gives basically all the language grammars and parses it to abstract syntax tree, which we can use basically to derive all these type of relationships. Okay, so a few definitions. What is a parser and what is a grammar? A parser is a program that reads source code as plain text and turns it into a structured tree of named nodes. Okay, the abstract syntax tree that represents the code syntax. Let's look at what AST is. For example, we have this very simple Python file on the left side. We have a function that adds two numbers, right? You define an add and pass a parameter A and B, and then you basically assign C to A plus B, and you return C, right? And then you define a main function, that's another function, and then you print the output of a function. You basically call the function with some arguments, 1 and 2. Very, very simple, like hello world example kind of in Python. And then this is a Python way of saying, if this is a main file, what function should be run when you basically run that file. In this case, it just invokes main function, right? And then it will do whatever is inside that, right? It will print the output. If you want to represent this code, and this is a Python, right? But imagine any language, right? Right now we're talking about Python, but it could be JavaScript, TypeScript, C++, or Rust, right? All the languages, they have their own associated abstract syntax tree representation of a program. So tree-sitter is one way of doing it, but there are also native libraries that you can use to construct this AST. So what it does is says, okay, so this source code is equivalent to this graph because it says it is a module and it has two function definitions and one if statement. As we can see, one function definition, second function definition, and if statement, right? And then first function definition has parameters A and B, and it has a body and block, right? What is that? And what we have inside that? What we have inside, we have assignment. And what is a return statement? It's a C. Well, obviously, so there is also like, apart from abstract syntax tree, you can also have concrete syntax tree, which has all the language-specific syntax in it. But for majority of use cases, you don't care about language-specific syntax. you care about the overall relationship, right? And then in this case, second function is the main one. And then you can also include here the main. This is for simplicity. It just says what are the parameters and what is in the body. And here you see the parameters. It doesn't have a parameter. It's empty. Body is like it calls print, right? Print function. And then it has an argument list. That's a specific construct in a tree-seater. So function definition is also a construct, right? Irrespective of a language, each language will have function definition, right? Each language will have print. Each language will have argument list, right? And then it will call add, and then in add it will pass an argument list, would be 1 or 2, and so on. Everything imagined could be represented as a graph, and then when we have this, it would be easier to use to construct our graph of all the relationships. So Code Graph RAG is multilingual. So what it means, it supports many languages. In this case, I think right now we have 9 supported, and some are in development. And as you can imagine, the reason why we have this is not as easy as say, oh, let's because tree-seater is universal, we can just plug in any language, it will work. It will work, but it will work partially because there's a bit intricacies how to construct the exact the full relationship and nodes we really care about. So there is some kind of a scaffolding around it that needs to be done after we convert into this AST. So what happens? So tree-seater comes with a grammar, and let's look at what grammar is. Grammar is the formal rule book of a programming language, like Python, Rust, and so on, right? And the rule book it tells the parser which token sequences are valid. Like in Python, you have a def, which is a valid keyword, right? If you say fn or function, it will be invalid for Python, but it might be valid for, I don't know, for Mojo or if you say let, that's not valid in Python, but it's valid in JavaScript, in TypeScript, right? So basically, those are kind of a rule book. So which token sequences are valid and how to group them into syntactic units, right? And it will understand that this is a function in Python, function in TypeScript. A statement is a bit different, but they mean statement and expressions, right? So those grammar are kind of a unified, they are representing any language into one form. And tree-seater ships many grammars for Python, JavaScript, and so on. And if we go to, okay, we go to Membrock Lab, and we go to tree-seater, and then you will see in their GitHub, we have, yeah, hold on, so that's, yeah. In tree-seater, we have Python grammar, tree-seater Python. We have JavaScript, Go. Those are bindings, by the way. But you get the picture. We have OCaml, Scala, any language you can imagine. It is available there. So Code Graph RAG uses those grammars, basically. What it does, it uses the grammar and parses those into AST. And from AST, we extract the entities relationship that Code Graph RAG has defined, that I showed in a previous slide, right? And then and construct a graph with those relationships only. And the extracted from AST are like modules, files, classes, right? All those kind of relationship that we talked about. Yeah. Okay, so that's about tree-seater. So how grammars are loaded? I'm just gonna go quickly here. We have tree-seater grammar, we have parser loader, we have AST patterns per language, right? One loader brings a parser for every supported language at startup. When you start CodeGraph RAG, it just loads any parser you have installed. But you can also, if you have a missing bindings, those are compiled on the fly. But if languages are if for some reason in any of the language fails, it just continues without that. So the program continues to work. It doesn't stop there. And this is by design. This is a choice I made to make, even if some relationships are missing, it's still fine, right? If you're looking at the graph. Yeah, so per language patterns translate raw abstract syntax tree nodes into function, class, and module entities in the graph. So that's pretty much how it works. And then if we look at now, I'm gonna do some demo now of CodeGraph RAG, and I will show you what languages are available, and then how you can add a grammar of your own language that is not shipped by default, and see how it actually works. Okay. Okay. If we come here, what we have. Let me just zoom it here. Zoom. I think it's good, right?
Yeah, I
Okay.
think this is good. This is good.
Yeah. So, uh, CodeGraph RAG is a terminal. It has a terminal CLI. It's basically it's similar to Cloud Code or Codex CLI that you just interact in a terminal in a Bash environment. So, and if you look at CodeGraph RAG repository, it is actually hosted in Codeberg. It used to be in GitHub, but there were some issues with my account. That's why I moved it to Codeberg, which is an open source distributed GitHub alternative. Okay, and here, if you go Codeberg Vitali 87 CodeGraph RAG, so this is basically my repository, and here I have a description and everything, how to install it, what languages are supported, right, and what are in development, and also the latest features as well. And I try to keep it updated. Yeah, but I will welcome any contribution, any support for this open source project. If you are really interested in in those type of agentic development on graphs. Yeah, the README is very long, but what I wanted to show here is like installation is very straightforward. You can follow it later if you like, and then install it for Mac, for Linux, and so on. Obviously, for Windows, you can do Windows WSL, Windows Subsystem Linux. So everything should work on Windows as well. So yeah, so when you install, you need to do kind of some syncing using UV. It's primarily using UV Package Manager, and because it's extremely fast. So now I have already installed CodeGraph RAG, and then I activated my virtual environment. If you look at which Python I'm using, is using my virtual environment Python. And then when you activate, when you install, when you are ready, it's very easy actually. You can do CGR start, and you can even look at some help to see what options are available. CGR start is one of them, but CGR is the entry point, and there are other options available after that. But we are gonna primarily look at the CGR start and also a bit about optimize. Okay, so in this case, what you do, first of all, you want to index a repository. By indexing a repository, I mean you just do exactly this. You have what you have. you have you take a source code and you convert into graph. Okay, so that's pretty much all conversion and indexing inside the graph that happens there. By indexing, in some domains, you might understand like it just index in order to look up faster. That's a part of it here, because the graph database, in this case memgraph, does automatically. But yeah, in when we use an MCP server that is also available, you will see that why is it called indexing? Okay, so not to confuse by just general term of indexing. So how you do that in CodeGraph RAG? So you do start, right? And so when you start, you want to specify which repo you want to index. And then in this case, I'm saying, okay, let's index our CodeGraph RAG repo, and I'm putting dot here. But I can pass any local folder that I have in my computer. For example, I wanted this Microsoft what is called ASP repo. I can clone it and I can point to that repo, and I will say update graph, which means I'm just why I'm updating the graph, because I might have some information available in a graph. I would like to update that, and I can basically wipe whatever was there in a graph and start from scratch. So I don't want to go much into details, but actually it is possible with CodeGraph RAG to combine multiple repositories into one graph and then query them all together. But that's kind of an advanced use case. Right now, we're going to only index this one. And when you do that, you can see it's just starting to run, to go through all the possible functions, folders, looking for relationships, external dependencies, and so on. And now, the reason right now we are having this embedding failure here, because Quadrant, which is another database, is locked. That's why we are not. I'm going to cancel this embedding part, which is not important. But I will tell you what that embedding is. If you remember, I said that you can do you can embed information and then have this semantic search, but you can also have this graph search. So CodeGraph RAG supports also semantic search. You can also embed, let's say, files as a text, and you can retrieve also as a in an embedding space. You can also retrieve some information by looking just vector similarities, which kind of complements what GraphRag does. But in this case, it's not important. Okay, so I showed how to basically index a repository, and now like everything is ready, and it says flashing everything to the database, flash complete. So everything is in a memgraph and it's disconnected from memgraph. We basically we drop these kind of embedding nodes because we don't want that. We want only those kind of relationships that we were talking about. Method overrides, I don't know, all type of other type of relationships, and so on. If you really want to understand how this works under the hood, the only way to really understand that is look into the code that is available in Codeberg. So feel free to do that. And if you have any questions or issues, then there are issue tracker, and I'm just putting in issues and I'm trying to solve them one by one. Right. When we have that, so what we can do is just start an interactive agent. And how you do it, you just say CGR start. And as you can see here, we have It gives some information what type of bindings it's doing, which in this case is not important, it's about C#. But most importantly, it gives information what type of agentic model we have, and what type of cipher model we have, and if we have enabled editing, and what is the target repository. And we're connected to the mem graph at this address. And you can ask questions. It just gives some really nice prompt, and all kind of grammars that are loaded successfully, right? As you can see, we have those many languages loaded. And we have also file reader, file writer for editing. And those point to our same code graph RAG repo, but we could have pointed to any repo. Yeah, so we have also shell commander, document analyzer. Those are basically the tools that are available to an agent to interact with. Okay, before I go and do some agentic coding there, I want to just finish here to say, like, actually let's look at the languages available in a nice before we do some coding. So if I just quit here, CGR also has, as I mentioned, most of the time you'll be using start, but also you can look at what languages are available. And then under language options, we have also sub options here, in this case, list languages. And it will show you very nice table of what languages are available, what are the extensions that each language supports, like Python, JavaScript, those are the files, TypeScript, those ones, Rusty.rs, right? What type of function types are there for each language? For Python, it's only function definition, but for JavaScript, it's more advanced, like function declaration, generate a function declaration, function expression, arrow functions, right? That's now I guess you can see why this is important to have language specific language specific grammars and tree-seater parser. So we have different classes and also call types, right? Those basically come from the language grammars, and then how tree-seater recognizes those for each different type of languages. Another command that I want to show you is we can add, okay, we can see there is no OCaml language here, right? Which is another language that, let's say, if you're really interested in and you want to add, you can just add that, and you will have a basic support for that language. We can just say CGR language, all right? So language, you can add grammar or camel. Tree-seater, sorry. Tree-seater or camel. If you do that, what it will do, it will go and look for specific, actually, this was the correct OCaml. It will go and the slide is wrong, actually. It should be without this tree-seater, just an OCaml. And it goes and looks for tree-seater grammars that are available in a tree-seater GitHub repository. And it says if there is a tree-seater OCaml, right? And then and add that as a sub-module, and then tries to support that language out of a box. But out of a box support is very limited, and most of the relationships, I guess the basic relationships could be shown in a graph. But yeah, most of the time, if you just want to get a feel of a language to poke around, this is a great way of just adding a language. But if you really want OCaml to be supported, it needs to be properly added to the code graph RAG repository, and you need to create an issue, and then I need to assess the capacity, and then do a bunch of tests. Because if you look at code graph RAG repository, it has, I guess, a shy of 4,000 tests already written, and it's too many. So okay, so we have tests, and then it's like lots of tests are here. As you can see, just endless for each language. We have all the tests, and then also like functionality of the code graph RAG as well. So every time we add a new language, I have to test like every type of relationship, import, and so on works as expected by writing some simple programs, and that covers all possible edge cases. That's a proper way of adding languages. Yeah. Okay. For some reason, it's taking too much time to do that, and I think it might take some time, but it eventually will finish. But we can add another instance. That's fine. Okay. If we go back to our slides, we basically covered those, and now we're coming to the second part of code graph RAG. So the first part was you create a graph, right? You have a source code, and you do some fancy parsing, tree-seater plumbing, and you write all the type of tests and try to capture a relationship per language by using tree-seater grammars and so on. Let's say you have the graph. How are you going to use that graph to do a useful work, right? Because only visualizing the graph is fun, is nice, and it's good to understand how the code base looks and then try to see the relationships. But now, if you really want to use it for your workflow, for your agentic flow, you really need to put that in action. And then the way you do it is like you need to give instructions to the agent how to use the graph, what is the schema of a graph, what type of relationships they are, what type of nodes they are. So the AI agent can use those to query by writing a cipher. So, and I will tell you how it works actually. So one thing that is very nice about tree-seater and the recent tools in general and how code graph RAG does it is like every time, let's say you're in a code base, you change a file and you drop a few function. So obviously what you expect in a graph, those functions to be dropped from the graph itself, right? It's very kind of a reactive in that sense, like it keeps a hash from the previous run, and then if there are no changes, it just returns the graph. But if there are any changes, tree-seater can actually detect that these incremental changes and then trigger recomputation on these modified parts, and then you will get your graph updated, basically. And then every time you get an update, everything is written back to the mem graph, and then and also like the hashes are preserved because you don't want to recompute every time. You want to know that this exists, and next time it will return if there are no changes. So this is nicely done. And yeah, we already saw like we ingested, we did CGR start, and we actually did on our own code graph RAG repo. We passed the repo path, and we basically processed all the files and we wrote to the mem graph. And we already done those queries, but we could have seen like how many nodes and the relationships they are. But those are already in the mem graph. We have seen it. We can also just retrieve, all type of what labels are available, basically what nodes in this case, and nodes and relationships are available. Those things can be obviously queried. So if we go to now the agentic coding, before we do that, I mentioned like very briefly what the cipher is, and I promise that I will dig a bit further. Cipher is like again, it's a declarative language to query the graph, and it's as you can see, it's very easy. It's just a pattern matching search, and it basically tells Cipher what to find. Like you can say this is a module. I want this is a R relationship, an F function, right? And you can do where, you can filter even down, you can return, you can order, and you can limit it by. And you can also do kind of a variable length path search, right? Your query does not need to be like all kind of relationship. You can even look at up to 3-degree or up to 3-hop relationship. In graph theory and graph construction, hop means like when you're hopping from one node to another node. If you are hopping once, that one hop kind of a distance, but you can imagine like you can have multiple hops, 2, 3, 5, right? And then it grows as many relationships they are from each of the hops, right? The first hop might have, let's say, 2 or 3 nodes, but if each one of them they have 3 themselves, that's kind of it grows exponentially. And you can also do count and collect similar to SQL to aggregate the counts and so on. Okay, for I guess for the I guess for let me see. I'm thinking to run this or not. Maybe we can run this to see the final. Let's say we want to see what module defines what function. Yeah. If we do that, so where we are saying that a module qualified name, that means which module we want to look at. We want to say code graph RAG, code base RAG main. I want to only look at this module. Okay, and then we're saying return. Okay, return function name and function path. Because it's a module, it will have a name, but it also will have a path, right? Because it's a module. And as you can see, it's very particular, the language. It really doesn't like the spaces. And what we're saying, okay, just order by function name. We don't have to do that, but sometimes it's easier to view it. Yeah. Right. When I run this, as you can see, it says this code graph RAG code base RAG main defines those functions, and those are the functions sorted, right? And those are all the functions that we can see there: run chat loop, run optimization loop, and so on and so on. Even like semi-private functions that are internal to that module, right? So this is one way to do it. So, but I don't want to do all others, but I will share the slides. Obviously, you can try it yourself. Right. Now let's come to using an agent. When let's say we know how to use Cipher, we can write Cipher in memgraph or even using a CLI, and we can query our graph. But we would like to teach an LLM to also do that. Luckily, LLMs, they know Cipher really well, and those proprietary LLM models are really good at it, like Gemini, GPT. Okay, so this is GPT 4.0 because it was really fast, but you can even use like open source model running Olama locally, you can set it up to run locally if you don't want cloud hosting or this external provider APIs. They're really good, but we give some instructions in prompts in a code graph RAG, and the AI reads them. AI reads them and then follows that instructions to understand the ontology, everything that it is available to it that it can use to run it. So we have orchestrator model and we have cipher model. Okay, so how our agent works in CodeGraph RAG. Basically, we have two agents. One is this orchestrator agent, which is the main one, and the second one is a cipher cipher agent. Basically, it's a composition of two agents. Orchestrator agent basically takes our natural language queries. For example, a user asks, which classes implement the repository interface, right? That could be your question. Orchestrator model takes it and says, user intent is to understand the implement relationship, right? Or depending on the language, so this could be interpreted like, which class implement, which classes implement this repository interface, right? It needs to find what is the repository interface and which classes actually implement those repository interface. So, and it says, okay, now it says rewrites, if it needs to, it rewrites our user prompt in a language that a cipher agent will understand and say, okay, now generate a cipher that looks at classes that have implements relationship to which interfaces, right? And it says if you find all of them, right, orchestrator agent doesn't write cipher. It just instructs cipher agent to write that given a natural language. And the cipher agent takes that revised prompt and then runs this cipher. And then, it just looks at if this ends with repository. Basically, it wants only repository interfaces. And then it returns that name and order by qualified name if there are many. So let's say if cipher agent does something wrong, it fails, it might return, say, you know what, I couldn't run the cipher, and it returns what it has written, and orchestrator agent will look and say, okay, let's try a different way. If, it's an agent, it can just interact and then decide what to do next. And obviously, when the cipher is executed, it is retrieved from the mem graph, and the results are passed to orchestrate the agent. Let's say if this is nicely returned, an orchestrate agent will say, okay, now I have all information to reply to the user. And then it constructs the nicely formatted output to the user, right? And now we'll run and you will see it in action. Right. If we come here, okay. Right now, since this adding grammar still works, it says auto-detecting language OCaml, using language name OCaml. It actually auto-detected file extension, and so on and so on. And it asks me some questions, but I don't want to continue this because I'm not really interested in adding OCaml right now. But you get it. You can answer the question. You can have pretty good representation of OCaml added to your model. Okay. Now, if we do CGR start, and so I need to activate my virtual environment and start my CGR stands for code graph RAG. I think it was implied. Sorry, I didn't say that earlier. And now, okay, let's ask something about our code graph. I would say, how many functions are available in this repository, right? So I'm asking this question and I'm clicking Control J. Okay, so the problem now we have this issue is we haven't passed any API key. So as you can see, it's just complaining like you have chosen Claude Opus, but you haven't passed the API key. So I'm saying, how can I just use that? That's why let's use, so we're, so now I'm reading an API key that I have stored securely on my password vault. And then I am specifying what is my orchestrate API key is and my Cypher API key is, right? Because as you can imagine, you can have different model for your orchestrator and maybe smaller model for your Cypher, which might be a local model. This could be Google, this could be OpenAI, and so on. I mean, you can really swap them as much as you like. And then we started. Now, how many functions are available in my repo? Now it should work because we have all the API keys available. See what it's doing. Now it received, we'll go line by line actually. It received a natural language query. How many functions are in the repository total? But see, I asked differently. How many functions are available in my repo? Orchestrator model, and it says, okay, now I'm going to use this tool, query graph, and then I'm going to pass this natural language, which is a bit rephrased version of what I asked. How many functions are in this repository in total? And then Cypher generator took that. It says generating query for that one, and it writes the Cypher. Yeah, match f function return count f as total, and now it just returned me the total count, and then this result was passed to orchestrator, and orchestrator gives me the final output, and says repository contains that many function. This count comes from querying the codebase knowledge graph, which tracked all the node label function across the codebase. Let me know if you like a breakdown, for example, blah, blah. Similar to how you will interact with Cloud Code. And I might say, what about methods? Those result doesn't include methods, right? Or I can ask anything, and it will just go and do its stuff, right? Yeah, so it's executing, and it now returns very nicely about breakdown, distribution functions and methods, and total callable units. It calls. Okay, what else can we do here is do some editing, right? And it's a full agent, so it's not only for reading information from graph, but it also can do editing. But before actually editing, I want to show you how it works in a hybrid mode. Right now, any question we asked, it queried the graph. But if I say something generic, what is this repo about, and anything that needs some exploration, it doesn't need graph query, it will go and do this grep search, similar to how Cloud Code works. So can you tell me what is this repo about? Can you give 3 big highlights, right? I'm asking this question, and now let's see what the agent decides to do. Okay, it's this report. Okay, so this repo, not report. So this is me basically being lazy and not typing. But now hopefully it will just, now it's doing, right. As you can see, first it did some Cypher query, try to understand packages project and what are the names there. And then now it's reading a file, right? And goes and reads the file, which is a README. That's what I would expect it to do. And reads the file and gives me the answer. Right. So, and it gave me 3 highlights, right? Big highlights. Okay, nice. Now, what if I want to say, I just want to change my README to include those 3 highlights at the beginning. Can you please edit the README? Now I'm asking a edit operation, and that could be destructive operation. So the way CodeGraph RAG is designed, like it asks your permission, similar to how other agentic harnesses do. They ask permission for potentially destructive operation. In that case, edit is one of them. If I send it, now it will just give me, it will go and try to think how to do it, and then come back and say, do you want these edits to be done? As you can see, it's saying, okay, to replace code requires approval. Do you want to add this? As you can see, it's very nicely highlighted. Basically, it didn't do any deletion, it just did addition, right? Let's say, yes, I'm okay. It did surgical block replacement in README. And yeah, we can talk about what tools are available to an agent. But for now, it just did partial replacement inside the file. That's why it's called surgical block replacement. Okay, now now it did that. But if I wanted to say, okay, I want a 4th highlight, and I want you to drop the 1st highlight, and I want to show that it can do a really nice diff with addition and subtractions. And for simplicity, I'm working on yeah, I really like knowledge graph storage in memgraph, please. So I would like to show that it can really show a nice diff view that you can visually see what it's actually doing. It doesn't yet support IDE that you can open at the side and see the edits, but you can see in line what are removed, what are added, removed in red and added in green, yeah, and so on. Okay, let's say no, don't do that. And the reason, it's okay. There are no reason. You can reject, and then you can give feedback, similar like how we say, oh, maybe the edit is wrong, and so on. That's how it basically the agent works at a glance. Yeah. So to sum up about CodeGraph RAG, what it is, it's basically it's comprised of 2 parts. One is graph building. The second one is agentic processing, right? And we saw how it works. Basically, we constructed, we indexed our repository, and we also asked questions about our repository, and so on. So if you remember, I skipped the semantic search. I'm sorry. Okay. Okay. So okay. So I skipped the semantic search, but it is available in CodeGraph RAG if you install the semantic additional optional libraries that will and if you install Quadrant VectorDB, it will be available. So what it does, you can, instead of just querying graph only, you can have a source code, and you can chunk the source code and embed those chunks as vectors, and then put it next to your nodes, and yeah, and then you can also retrieve those semantically. And retrieval tools are like get function source and get code snippet, right? And then you would like this to be used, basically. So how it works? So if I provide a natural language query, which is by with my query, I wanna extract something that is, I'm not looking precise information, but I'm looking for semantic information. So the orchestrator agent might interpret that and say, oh, it's not precise, then let me invoke semantic search tool that I have, and then it will go and search the code base semantically instead of going via graph or going like grep search. Yeah, and then obviously you can return top any results from that semantic similarity, and you can slice and filter based on similarity score and drop the ones that are weak matches, right? So that's how it works. But this is, by the way, it was a late addition to the project because some of my users, they really wanted that functionality. That's why we allowed that um, to also coexist with others. Now, you saw how we edited our README file, right? But how actually this AST-based editing works, abstract syntax tree-based editing works. Let's say we have a target function and we ask to edit it, right? It locates what function we are talking about. This function, this is the target. And because the function has a start line, end line, and edits, the surgical edits you also pass. It also has start line and end line. It knows which part to edit. So it basically proposes delete code and add code, and everything lines up really nicely when you just then execute that and edit your file. So, and this is like a very exact replacement. So one additional workflow that I added myself, and I don't know how helpful that was for the community, I've never checked it, that you could use this to do code base optimization as well. What you can do is you can say, okay, analyze the graph, detect anti-patterns, and then you can propose suggestion, and when ask approval, you implement the change. And what you can do, you can add, you can say CGR optimize Python, for example, the Python part of your big repository. If let's say it's a mono repo, you have multiple languages inside one repository. You can only say, okay, I want to optimize Python, and this is my repo path. And this is a reference document that I want to optimize against. What it means is you have, let's say, coding standards or a book. Sometimes I pass a book and say, just take the best practices from that book and suggest optimization for my code base, and it just does it. So that's one way to also use CodeGraph RAG. But in general, like so agent has read file tool, create file tool, obviously, right? If you want to create a file from scratch, it will use create file tool instead of replace. Replace is for existing one, that surgical replace. This is a write tool. This is a kind of a fallback when something happens, it doesn't know how to, or the changes are so many that it decides it's better if it rewrites the file basically, instead of doing this many surgical edits. Yeah, so this is pretty much what tools are available to an agent. Now, one thing I wanted to also mention before I go and finish some code, some hands-on AI agent demo, is about MCP server. So CodeGraph RAG, as you saw, it is a coding agent itself, but it can also be used as a MCP server for other coding agents. And most notably, I would say people want it for Cloud Code. So now we have this Model Context Protocol. Whoever doesn't know, Model Context Protocols, or MCP, is an open protocol that enables LLMs to connect to external tools and services in a standardized way. And it's very easy to basically connect to any tool. If you find like it could be useful to connect to that tool and then use it, right? So, for example, when we have Cloud Code, if we add this MCP server, which is a code graph RAG that it will be running in the background, Cloud Code can query this MCP server and send a request and get a result back, basically a running code graph RAG, which will be basically interacting with memgraph. Yeah, because Cloud Code natively doesn't have, well, as far as we know, it doesn't have any graph traversal, graph querying. It just does grep or rip grep type of search, going file by file, right? Just looking for information. But if your question is about it's more suitable for graph queries, it will understand to invoke that and then query code graph instead of its native search tools. And MCP ships with those tools, as you can see here on the right side. We have list project, delete project, wipe database, index repository, update, anything that you can expect. Basically, it can do all the stuff like Cloud Code can replace pretty much all its activities with Code Graph RAG MCP tools, and it will be as performant probably as before. So this is about MCP capability. Now let me actually show how it works. If we I want to start a new Claude instance. Okay. Now, when we have this Claude, which is initialized here at this code graph RAG, and as you can see, we are on the main branch, and I will say, let me ask the same question here to see if it can. I have already installed MCP server onto Cloud Code. If you want to do that, there's an instruction in the README in a Codeberg. You can have a look and then try to do it yourself. But it's already installed here. So how many functions are available in this repo? I'm just trying to see if Cloud Code will realize like it has the tool to do that. Okay, so it's doing search itself, but that's interesting. So you have a code graph RAG, a CGR tool, MCP server, so you can use that. Why it put here, I don't know, but see now it realized it has those, and now it can make the query using an MCP instead of just going this suboptimal approach, I would say. And you could see how fast that was compared to what it was going to do. Actually, now it would be interesting to benchmark against without asking it to do with code graph RAG and see, can it just, if it goes natively, how long it will take. Okay, let me actually copy paste this question here just for benchmarking to see the speed difference, right? If we were to, let's see if it's an accurate, first of all. Secondly, how long it will take. Now it's doing grep. It's still going. Okay, I think you get the picture, right? For those type of questions, Claude will spend so much time and so much tokens. Well, this is a subscription thing, but imagine if you were to um, use it yourself, then that would be, and there's a bit of mismatch how many um, function definitions there are, and it's probably because some of the repositories are included or excluded. Okay, but that's the idea. So, um, yeah. So you can use Code Graph RAG separately as an agent. You can ask questions here. Um, and yeah, you can ask questions, or you can use it as an MCP server inside Cloud Code, or any client. Actually, you can have a Cloud app, you can have codecs, whatever. You can integrate that because it's just an adding some information in a JSON file, and then and most of the agentic harnesses they can easily plug in the MCP servers. Okay, that's about that. And then we saw the example here, and I want to leave some time for questions, but please check the repo. This codeberg.org with DAL87 code graph rag, and also you can connect with me in LinkedIn because I post a lot about AI and agentic coding, also innovative projects that I have been working on. For example, recently I've been working on creating my own IDE that is very native. It's like running in a terminal, but it's an IDE as well. So, or projects like splitting big PRs into multiple reviewable PRs, and so on. I mean, if you go to my a profile in a Codeberg, you will see different repositories that I think are useful for productivity in general. So with that, so I'm happy to take some questions.
Yeah, thank you, Vitali. Um, I know Mina's probably going to anchor the Q&A session, but I just have one question. This is a very random question. Your slides,
Yeah,
yeah, did you prompt them? What did you use to generate
yeah.
those?
Those slides are GPT image 2. Those are images. Those are not slides, actually.
So basically, you gave him the content and asked it to. So
Yeah,
what
yeah.
was your prompt?
You need
Yeah.
some iteration. Obviously, it's not
Mm-hmm.
perfect.
Mm-hmm.
As you also notice, like with three-seater language adding, it just makes a mistake even if you tell what it to do.
Mm-hmm.
But it's pretty good. Like especially, I
So
wanted handwritten style.
yeah, okay. So I want to know your prompt. What were the key prompts? Because I want to know what that technique is called. What were your prompts? That's what I'm looking for.
Oh, so the way I did it, I don't know if I can show. Should I stop my sharing or? Uh,
No, it's fine.
okay, so obviously, my technique is I go to my code graph rag repository and I want to create slides based on it, and I prompt Claude and saying this is the information I want to put in my slides. Give me a breakdown of slide contents, and let's say it gives him 10 different slides, right? And then I take each one of them and I put in GPT image 2. Sometimes I chunk them like for a few slides at the beginning. They were not like I'm not copy pasting all of the section, but part of a section, and I'm asking just put this information in a nice format, and I just go this one by one. Basically, this is for me also to make sure that everything I follow, and it's a bit slower, but you can also automate that process if you really like, right? You can just call an API. We can do it for you, but I'm not sure about the accuracy. So yeah, it's going YOLO mode. It's a bit dangerous.
Okay, okay, okay. So that's. I'll ask other questions after. I guess you could take. Yeah, Vitaly, maybe you can stop sharing now.
Yep,
We have the infinity loop.
as
Yeah,
an
let me.
infinity screen. Yes.
Yeah. So Mina, you could.
Sure thing. Firstly, Vitali, thank you so much for the presentation. I think that was fantastic. It was a really high level overview of exactly how CGR works, how we can be able to apply this with agentic systems and everything. I love that. And I think for some of us that were following along with the code base now from the repo that you had shared, that was fantastic. I think from my end, I have a number of questions. So personally, for me, just to give a bit of context, I work a bit in the cyber security space, and so looking at things like pen testing, CGR is something so valuable because we need to go through so many different code bases,
Mhm.
analyze them, and I think this is something that is really applicable to something like that, right? So I just wanted to find out, just to contextualize everyone, how did you come across or start building something like CGR?
Yeah.
What is the inspiration behind that?
Yeah. Good questions. Okay, regarding the cybersecurity and the use of CGR, when I created it, I never thought about cybersecurity, that how useful it might be, but it turned out like people are using it for those purposes as well. Because some of the even really big company contacted me and saying like, "What are your plans of commercializing? What do you think about like can it be applied in cybersecurity?" And the companies were really like in that space, and they had their own product, but they were thinking about incorporating that, which was very nice to see. um, so secondly, how I came up with this idea. So um last year and a half, like mostly last year, during this last year, I was working with unstructured data a lot, because at our company we process lots of unstructured data. We convert them into graph. Those are mostly like you take a PDF. There's some logic in it, and you are trying to represent logic inside this messy unstructured PDF, and then in some graph form. Um, and I was using lots of coding agents. And then naturally, it was like I was really frustrated sometimes that the coding agent couldn't use that, or the structured language, or I thought, or in other words, I thought, what if you have the structure in a code base as well? That doesn't have to be a messy PDF about any topic. In that case, a healthcare, right, or legal, but it could be just a code base. If it's nicely represented as a graph, why not to use that as a context and then do your agentic coding? And I looked up the web and tried to find a really good repo, and I thought probably there is someone who has already done it. It's not like a very innovative idea in my mind at that time, but I couldn't find a really good implementation. And that's how it should go. Like with most of us, like if you don't find anything you like, you just build it. And I just built it, and it just took off really fast. Really, like in GitHub. Uh, like 2 months ago, before I migrated, it was like almost 3,000 stars, like 300, more than 300 forks, which means people are using it, starring, liking it. So um, yeah. So but given the GitHub is having lots of issues recently, so that was one of the reasons, migration. But the other reason was like if my account was categorized as a spam for some reason, and it was deactivated. That's why I just moved to Codeberg.
I see, I see. I think that's fantastic. Thank you for outlining that. And
Sure.
I think just building up on that point that you were making about the unstructured code, sorry, the unstructured data or
Yep.
itself, I think that's one of these challenges now contextualizing to the African space itself that we really struggle with, right? You'd
Mm.
find that a lot of Africa's data or the knowledge itself is in disconnected silos, right? So you'd find community health worker records in one county, agricultural extension reports in another, mobile money logs somewhere else entirely, such issues like this. So just building up on that, how does GraphRag's ability to traverse these kinds of relational knowledge graphs help us build AI systems that actually reason across a lot of
Yeah.
this fragmented data itself?
By the way, to make you feel better, it's not the problem is not only in Africa. I mean, even in US, you,
Yes.
you find like even in a healthcare administration, there's so much paperwork, silos, like information floating, duplicated everywhere. Look, the problem is even in most advanced countries in advanced systems like healthcare. So it's not only Africa. I'm originally from Armenia. It's also very bad there. Like paperwork is like a first class citizen everywhere you go. It's like hard copy and so on. Very hard to digitize, right? So it's gonna be with us. So you're right. We need to some way to that. So how to use code graph rag in that way? So code graph rag should be used in I would say if it's a code base, because right now it works with code bases only, right? There were some proposals to add um, converting markdown files into graph as well. So the workaround would be if you have lots of scattered information, PDFs, files, and so on, that could be converted markdown, which could be treated as a code and converted into graph. That could be one way. Uh, but in general, LLM assisted coding is, I think, it's a really good way to give your what type of entities and relationships and a knowledge graph you want to build from your corpus. You just prompt it really well, you iterate a few times, and you basically extract information from those sources. So and to be honest, for AI it doesn't matter how it is stored as long as it can be read. Like even as image is great for AI, right? So it doesn't have to be could be image, could be, I don't know, in some database with some API access. uh, like right now the barriers are so low because you can just ask an AI to interpret that information, and you need to give that information somehow. Um, yeah, if it's a, as you said, in agriculture or in any space that the information is scattered and it's manual and paperwork, maybe just scanning it would be just taking a picture and then passing it. I know it's too much work sometimes, but yeah, just pass an information to an AI and give your intent, like what type of entities and relationship you are looking for, and it will do most of the heavy lifting, I would say.
Uh,
Fantastic.
Sorry,
Thank
hi Vitaly. Sorry, I was in the backstage for a while. Just realized that I couldn't, like, I was in the talk. Then I tried speaking. Then I was like trying to fix my mic, and just Sumaya just
Right.
let me in. One question I had, which I don't know if I asked. This is a question I had. Like, I wanted to get into open source. I don't know if you answered it before. What, like, as you explored, like, you have multiple open source works,
Mhm.
you might have thought, okay, hey, this is something exciting, but I don't have time to build it. Like, what gaps have you observed that you think like someone here can try and get into open source by building it, that you think is useful for several other people?
Yeah, that's a good question. So my approach to building openly, right, as an open source project is like, um, so I try a few programs or applications and then say, oh, I like some of the stuff it does, but I just hate how, let's say, it's slow, or it's over engineered for my use case. For example, why I created my own IDE, right? I would say, okay, that we have a VS Code. Why are you creating your own thing? A VS Code is actually, when you start the VS Code, it just takes a few seconds to load. And if you just want to look up a function, or just search a file, you don't have to wait these 5 seconds. Like this is like 5 seconds every time from your life. What if I can write something in Rust, right? And then it just be like very fast, and it will just, I can put all my shortcuts that I want, that I really like, and I would like it to behave the way I want it to behave. That's the motivation for me to build something like that. So I just created Croft for that. Um, for CodeGraph RAG, the motivation, as I said, was like, yeah, I want to visualize our platform repo, right? What we have, like, it's very big at the company. It was very messy. Like, is there like a tool that I can do that? And they were like, oh, you can use Neo4j, but it's very heavy. And probably you need to do lots of heavy lifting. That's why it's too much. So I'm going to do my own thing. And I guess I see two avenues. One is like you find a really nice repo that already does, let's say, 80% what you're doing, and then you basically contribute to that to make it better. So that's one way, right? Or you just create something that you really enjoy and you open source it and then try to advertise it. I think one thing the open source contributors they forget to do after they do open sourcing, after they open source their repo, is promote it. Like this promotion is like probably is the heaviest part from all this process, because you can vibe code lots of stuff right nowadays, even if it's a vibe coding is sometimes is treated as a negative term, but depends what you are doing and how long it takes. Like if you look at OpenClaw, which is completely vibe coded, but this guy spent months and months of just vibe coding every part of it, right? So that's kind of it takes time and resilience to build that, because you can give up, right? Anyway, so you open source it. Now you need to find a distribution channel. For me, I because I did my startup before and I had some connections with the Daily Dose of Data Science. This is like an Indian channel that they promote lots of open source project, and it's up to their discussion if they like it. They would just talk about it, and I messaged and said, hey, have a look. I have this cool project I just open source. What do you think about it? Without any question, he just posted it and said, oh, finally, graph RAG that actually works. And that was enough to just you know to shoot off from there. It's that's how I guess, yeah, the stages are: you find a productivity gap in your workflow, you fix it, you open source it, and then you actually spend time promoting it somehow. That was one way. I also tried to emailing some of influencers who talk about AI and so on, but that was a dead end. So, but at least you try something. I don't know. Does it answer Sai, or you wanted any different angle?
No, that makes sense. It's yeah, like based on I think it makes sense rather than finding some gap and trying to fill it. Like you observe the gap, so you know more about it, then try to fill it. Right.
Yeah, and it's a trade-off of like, oh, if I build it myself, I spend my time even like vibe coding it. Is it worth it? Sometimes it is. Sometimes it's not. Um, like probably I wouldn't vibe code an HTTP protocol, right? So this is like it's not worth it, and it's like I need to go into rabbit hole of understanding every probably detail of the networking in order to do that. But if I just see an application which is a bit more higher level, and I can just do that with natural language or with the. By the way, when I say vibe coding, I learned so much while building CodeGraph RAG, and I had no idea. Like there's so many programming languages there, right? Different syntax, grammar, and so on. And I learned so much about different, probably the languages, how they work. Some of them are compiled, some of them are statically typed dynamic, and some of them compile, some are not. And then those have this type of relationship, they don't. And even looking at the test files, it was like, oh, this is how Rust works. Okay, fine. Like that makes sense, right? And you become more and more kind of knowledgeable about those things. Yeah.
So
Fantastic,
not.
Vital. So
Sorry, I was just gonna say that like vibe coding get a bad rep because people are not learning this work.
Yeah, I think there is a danger. I mean, there are a few projects that I never cared about that I just, oh, just give me landing page. I just don't want to look at the JavaScript file, right? That is our HTML. That's fine if you just want to see how it looks, and then but if you really care about the program you're building, you need to first put an architecture. You need to do system design. I spent so much time in CodeGraph RAG at the beginning trying to put an architecture right, at least what I want to do, and just draw some Excalibur architectural diagram, put the places in scalability a bit, like what if and so on, and how my agent should work. Am I going to separate them into separate things, or I can bundle into two, graph building and agent in one place? I even have like a type inference system in it. And I was thinking, should I separate as a separate repo? Because in Python, you can have these type annotations, right? And MyPy or TY can do really good job at inferring the types. But what if you don't have any types? You need to know this, like this class is being instantiated, which means this is a type of that class. In order to know if this calls a method, then this is a call relationship I'm looking for.
Got it.
Right? So basically by building this, and it just branched out trying to understand the type system, how it works in Python. And then I went into, like, because we use also JavaScript at our company, TypeScript, and compared to how the TypeScript system works, right? So types and how can use it at the runtime, you cannot, and all this. Yeah. In short, if you just vibe code, for some use cases it works, but now it's called agentic engineering, not vibe coding. If you are actually engineering things, I guess, and if you are trying to understand, you are still in control of the whole process, that's still okay. If I know this function should behave this way, and I just don't want to run for or if loop inside it, that's fine, because I can do it, but I will do it slowly. I can delegate that part to an agent, but I need to get a grasp of all relationships and what is happening there. I was just roughly speaking that you need to be in charge of overall flow.
Got it. So that could be a follow-up repo from you that does like a CI tool that injects types everywhere for Python.
Oh
Yes,
yeah,
you already have it.
I have it. It's not complete, but it does pretty good job. But again, I was like, when I was writing it, I was like, I'm not the right person to write this. Why there isn't a repo already that I could just inject and use it? And there isn't, because of who cares about type inference probably in Python, right? So, but and also I had the question: should I rewrite this code graph RAG into Rust or TypeScript? I had so those questions. Yeah, you have a question? Yeah.
This particular thing you just mentioned, I saw your post on LinkedIn,
Yeah.
and I've been asked because I've watched many people are arguing C++ or Rust, plus Python. And before I say this, please, I don't know if you have time. I hope it's possible
Sure.
that you could maybe in the near future, building, if you want to build code RAG again, make it like let's be part of it. I would like it to do so good, so much good if you could follow it through. That's one. So
Yeah.
what is the future, because there's this battle between Rust, C++, and then like Python. It seems like Rust wants to take it from Python, and people are like, so what's
Yeah.
what do you think is the future?
Yeah. Actually, it's a very topical thing. Actually, right now there's lots of discussion in even open source community. Okay, let me go in two directions. One is pretty much for AI models. It doesn't matter that much which language you choose. It's very proficient in TypeScript, Python, C++, C, maybe not as great in OCaml or Zig, but if you pass a documentation, it still will do a great job. So the language choice doesn't matter that much. Okay, what matters is like, okay, are you writing system level program that speed is important? or memory allocation, or I don't know, you don't want anything to go badly, that you can just write in Rust. Probably that could be a good way. But if you're writing front end facing application, you can write in JavaScript, obviously, but it is shown like LLMs, they like types, so they default to TypeScript. Then I would say, okay, that makes sense to write in TypeScript, right? Because the linting and then the type compliance. So whenever it complies, it can just autocorrect itself really nicely. And whenever I'm writing even Python code, I try to put like type annotations and so on, and write all the tools to make sure everything passes. So secondly, even let's say you choose a wrong language for your application, okay, right? So you should choose a wrong language, and then you have problems along the way. But if you write really good tests, which I do in CodeGraph RAG, as you can see, we test like probably more than 4,000 tests, or maybe like around 4,000. I don't remember exactly. Like every time you can do this so-called red-green TDD approach, which is red-green test-driven development. So you tell an AI, before you implement the functionality, write the test and make sure it fails. Because if functionality was there, it wouldn't fail, right? So write the functionality, it fails. Now, when it fails, then go and then write the code to make it pass. So, and it's not only my opinion. There are some people who tried that. It's a better way to code with red-green TDD approach. Or in general, test-driven development is pretty suitable for AI. So why I'm saying this, it's connected because if your code is written in Python, you have lots of tests. So what you can do, you say, I want to convert this into Rust or whatever, right? You say, okay, now you have all the test suite. Take the old test suite, write in Rust, but make sure everything passes. And this is how some open source projects were basically cloned or converted or transpiled into another language by just taking the test suite. Like the recent really good example was Bun, was just written in Rust. It was in Zig. Or this Next.js that, the Cloudflare, they did their own version of Next. They took the open source project Next.js test suite and say, okay, now we are gonna, it still work. I'm not saying you just say, you know what, just take the test suite and then make sure everything passes, but at least get like 70% there. And then if you understand what Next.js is and what you want to do, and you can just keep on iterating on this. Now, this raises a question. If you want to open source a project, should you open source your test suite? Right? Because this could be like easily copied in a different language. Okay, if you don't care about that, that's fine. In my case, actually, I don't care, and I just wanted people to use it. And even some people just took CodeGraph RAG without even mentioning it. They created a similar version of it, and then now they have like maybe 20,000 stars or whatever. But it doesn't matter. It's like, if you want to disseminate information, that's fine. But I still believe if you are being inspired or you're deriving something from that source, you need to at least acknowledge it, right? So that goes into like open source ethics and stuff. But still, it's you need to think about like, open source is really great for reputation. Okay, you show like you can do that, and then people know you, they use your product, and it's good for your career and so on, right? But you also don't want it to, to give it freely to others, like without any acknowledgement and so on. Again, if you really care about that, but I'm saying like some people do, some people don't, and then I see lots of people arguing against and for it. So Some people even claim that open source is dead because of, even in my open source like CodeGraph RAG, I got some AI PRs purely. Even some of them didn't even understand what they were doing. They were just submitting PRs. And I was like, okay, that's not good. And what I did, I took an inspiration from Peter Steinberger, who is the creator of OpenClaw. And I asked him, how do you even manage your open PRs when you have this OpenClaw and you get like, I don't know, 1,000 PRs per day? And he was like saying, he said, well, I clustered them and I took the intent from there. I'm not taking the code per se, because the code is most likely poorly written. I can do it better. But if I just understand the intent of it, what they are trying to achieve, sometimes I prefer to get the prompt instead of the actual code. And then I can do it myself with an AI. And I actually, I took that idea and I said, okay, so that's fine. I'm not even in a capacity even to do one PR at a time, right? I'm a sole maintainer. I cannot possibly maintain this repo if they keep piling up all these PRs. And I also did this kind of a intent-based clustering, and I just tried to merge them into the same line of thing. So let's add those functionality, but also make sure I credit the authors, even if I'm creating a new PR. And I'm saying, okay, this is based on, or I'm cherry picking some of the commits if they are good, but I always credit the author, because that goes to my question, like, I don't want to steal something without crediting. Even if it's AI generated, they spend their time. Well, I guess if it's not completely autonomous, but at least like they gave me an idea that I'm using in my project. Yeah, this is me. People are too focused on a programming language now. What I should choose, what I should write. Just write whatever you are comfortable with. It doesn't matter. You can always switch, unless you know exactly the trade-offs at the beginning. Then choose the best one. But to be honest, I think, which one was it? Twitch or Spotify was written in, I don't know which language was it. Ruby on Rails, right? And when they reach like 5 million users, they realized, oh, it doesn't scale. Oh, but that's a good problem to have. If you reach 5 million users, yeah, the hire a team to rewrite it. Yeah.
I think we can even just relate to that issue somewhat, given the Zera platform, which is now NSK's platform ourselves. During our first day, we ended up getting rate limited because of the number of users and participants that came on board, right? And we realized that the framework that we currently had needed to change based off of now the numbers that we're pushing right now. Good problems to have, even though they're problems nonetheless, But thank you so much for that. I think I'll just now push on to the next question. This is from Mike that was in the chat, right? And he was asking, can we create hybrid retrieval? So combining knowledge graph with dense vector search or something of the sort. I think we can. I think the more pertinent question would be, how would you go about merging some of these different retrieval strategies?
Yeah. Depends. Okay, so
sorry, just before you answer that question, I'd also just like to couple it with this other one. Based off of that, how would you also compare how CGR has like its accuracy as far as now getting some of these query pairs to some of these other RAG frameworks that currently exist? Just to pair the two.
Yeah. So, by the way, the accuracy of CGR, there have been some proposal how to measure that, because it's kind of it's very difficult, I guess, and it's very time consuming to go and see how many relationship and nodes there are in a big repository to kind of take it as a reference and run it all the time. But in my test bed, I have like tiny ones that I know like the counts and so on, and then I check the accuracy there. But from now, here and there, I sometimes I get requests and the issues that some of the relationships are not there. So, for example, in some programming languages, some relations are dropped, and the reason why, and so on, there are some bugs. Right? This is a natural process. So that's how you just progress by fixing the program. So how to create a hybrid retrieval system, just combining dense retrievers and code graph RAG and all type of RAG and then re-ranking and so on, right? Well, I would say it depends on a domain. If it's a code, I don't see any better way, to be honest, to do for code other than what Cloud Code does with this search, this heuristic type of search, plus graph search that is already there. You just how code CGR combines those two. We also have this embedding, right? You embed files as a vectors, and you can also search that if you want to just understand, I don't know, some of the intent behind some of the functions. You don't care about the exact function, but it can just kind of retrieve that. But if you really think about like let's say Microsoft scale search, right? Let's say across documents, across services, and so on, and you can do with the graph with all this. How is it called? This search, this discounted retrieval systems and so on that just penalize for ranking wrongly and so on, right? All these like search metrics. You can use those in combination with knowledge graph, but the problem with the creating knowledge graph is very expensive, and it's actually is the trickiest part. Even in our company, when we're digitizing the graphs from the unstructured text, right? So this is the trickiest part, because you need to make sure like an agent or hybrid system with an agent that you're using to convert that is actually performing the way it's performing, because there is no ground truth per se. You cannot say this is a correct graph representation from this unstructured data, right? So if you knew, that would be easy, and for AI that's a heaven if you have verifiable way to prove that, but unfortunately sometimes there isn't. So to sum up, I would say if it's a code, I don't see any better way unless we add more and more relationships and maybe a language nuanced stuff from, let's say, tricita, like make it more verbose. But this is like also goes against cluttering the context window in AI. If you just give more information, that might be more confused. But if it's a general retrieval system, I don't know if this building of this knowledge graph will be beneficial anyway, like in terms of time and money, and also the accuracy, because you don't have a ground truth, right? Yeah, it's very tough.
Sorry, I mean, before
Yeah.
you ask,
Sure thing.
Vitaly, something hits me. Like, I don't know if I think this is what we have now. You know how like with LLMs, there's the mixture of experts architecture. Could you say that we have like a mixture of retrieval experts? Like you said, it depends on the domain. You know, because you highlighted on that. That's something
Yes, I believe, I don't have any proof that there's big companies that they provide really cool fast search or access to knowledge. They have this kind of a well, actually I know you mean the idea of having mixture of experts, right? So having this bespoke type of retrieval for specific type of data, I believe it is already in place. Like if you have lots of, I don't know, PDFs, maybe parsing it into a doc, it's worse than just taking an image of a PDF and then reading an image, right? I'm not claiming that this is better, but in some cases it does work well. Or if you have if you have a database, obviously that's straightforward. You just write SQL, right? You query it from there. if you have a PDF or if you have a CSV files. So I mean, you need to know actually, yeah, if you know that all your chunk of data is in kind of spreadsheet format and so on, obviously you need to have a better search targeted for that instead of just taking an image of a spreadsheet and passing to LLM or saying search for it. It can do the job, but obviously it wouldn't be as accurate as this programmatic search, right? I'm pretty sure there is a system that, like every system is hybrid, and even in LLM sometimes I noticed that people ask LLM to do lots of stuff, which you can do programmatically. Like you can say, what is like 2 plus 2, right? I mean, yes, LLM might do good job, might not. It's questionable because it's really bad at math. But why would you do that? All right. So this is a simple example, but imagine extrapolating in a bigger problem, which is a similar thing. I mean, some parts could be programmatic, and then you make a workflow that some processing is done programmatically and is fed to LLM, and the output LLM is also goes into programmatic way and then goes to LLM. And you need to know how to decouple all those things, which it's not an easy problem, but I mean, if you really understand the system and understand how what the strengths and weaknesses of LLM is, you can actually design a system that is token efficient and also like, which means like it's less costly, right? And also it's more deterministic, because asking an LLM twice 2 plus 2, it might give different answers. But if you know the deterministically, that will always give you correct answer.
If I can just add a bit of input to this, this is actually the basis of one of the conversations that I was having this previous week with two individuals who are now deployed as FDEs, which are forward deployed engineers, which a previous speaker had covered. And with them, they were mentioning exactly this. They have certain infrastructures that they use to query different data types. And so there's going to be a retrieval architecture that they have for images, for code bases, for what's the word I'm looking for different types of data, essentially. But like anything else that you're applying, especially commercially, it has to be economically viable, or you need to make sure that you're managing your resources. And then secondly, on top of that, the output needs to be a lot more accurate and efficient if you're going to be mixing all of these different kinds of frameworks together. And so, yeah, thank you for raising those points. And even onto just building onto that itself, I think another issue now contextualizing back to Africa, another issue that we face is access to energy. I think also, like the unstructured data, this is an issue that is global, especially now in this AI boom. But now specifically for Africa, how can we be able to use GraphRag specifically, right? So looking at graph traversal and at inference time, it's a lot more computationally heavier than flat vector searches, right? And so for for builders deploying agentic systems, right, in contexts where they don't have reliable power, think clinics in rural Tanzania or different areas on the continent, what are some of these realistic architectural trade-offs? Can GraphRag itself be made lean enough to be meaningful at the edge? How do you see that evolving over time as more people begin to use this?
Yeah, that's a good question. I actually thought about how to use code GraphRag in different domains, especially energy as well. Given my background, I did a PhD in energy actually.
Yes.
So, is it like, can we just use that? Let's say you have the generators, you have like consumers, you have this demand and supply, frequency control, right? All these type of really like intricate things that you can represent as a graph. I'm not saying specifically it's a code graph RAG, but if you were to extend the idea, you can. Yeah, the idea is basically how to create a knowledge graph from the domain you are really interested in, right? And you define the ontology basically of this graph. And for energy, it could be something like, I just want to know, for example, where my energy is wasted more, right? and you can just have all the sources and sinks that you just can map and see like where your what is your throughput is, and then just trace the lineage where it goes from the source to the sink, and see, okay, why I'm getting 20% throughput while in like advanced countries or like in the reasonable places is like 80%, right? You're like maybe 20% waste, but it cannot be 80%. By the way, it's really horrible in Armenia as well. Like it's not only, I guess, it's like, imagine like if you have abundance of energy source, that kind of implies you will be wasteful economy. It's in Russia as well and so on, right? So there is no like efficiency motivation of doing anything efficient because you have so much. Like in a mining as well, right? In mining, there is no incentive to reduce cost at all, because it's a return on, how is it called? The margin is like 1/100 or 1,000, right? Doesn't make any difference. So what I mean is, I wouldn't say code graph RAG itself could be expanded to those different domains like energy, but the idea, yes, could be taken, and then a similar kind of a schema could be constructed, and the relationship mapped in order to, even as you said, real time, right? You can plug in on a system to see what is my flow in real time. So from this node up to that node, right? And it doesn't have to be cipher query match. It could be some. There are so many like a graph theory, and you can calculate many things, right? Uh, the least distance, or multi-hop problems, all this type of data structure and algorithm kind of problems, right? Might be useful for this type of analysis in that domain. Like you would like to know, um, yeah, how many hops it takes to drop the efficiency by like 70%. If it's 2, well, that's bad. Okay, right? If it's like 10, it's okay, it's acceptable. I don't have a concrete answer to that because I'm still thinking cybersecurity was one of the things I discovered that people were interested in. Healthcare compliance is another thing that I am thinking very proactively that CodeGraph RAG could be suitable, because with CodeGraph RAG, you can technically detect any type of leakage in your system. Like, could it be like PHI, personal health information, or any violation of, let's say, a HIPAA or any kind of a compliance that you don't want your code base to expose, right? And you can track that if that information is being contained in a environment that is secure, or it's just exposed as a log, right? Imagine if it goes as a log and you just write a patient name in a log, that's a breach, right? You can actually do that to trace and say, oh, it goes to the log. Oh, but my source could be PHI information, but it goes and that says it's a log, right? Oh, that's kind of bad. And it will help a company to be compliant, but also it could be a tool for compliance auditors to go and then use that on to audit healthcare code or any domain code, right? Yeah,
Definitely,
I'm thinking
definitely.
about it. Yeah, short
I think
answer.
this. No, I completely understand where you're coming from. This can definitely be applied in a number of different areas, just depending on how you're going to be applying that specifically. Um, the energy sector, I was very interested to hear about that because I think this is somewhere where I've seen a lot of governments are looking to really optimize their energy usage and distribution. Again, now especially nowadays, given the AI space. But I think the question I was actually asking was now regarding to, if you look at the use of AI,
Mm-hmm.
computational, if something is computationally heavy, it's almost directly proportional to the amount of energy you're going to be using
Yes.
to make that compute, right? So
Yes.
more GPU hours, etc. So graph RAG compared to other types of RAG systems, especially flat vector RAG, is a lot more computationally heavy. Do you see it getting a bit more lean? Are there ways to optimize it to be less computationally heavy from just the understanding from first
Yeah.
principles about GraphRag?
Yeah. So,
Before we get to the last two questions.
yeah. You are right because of test time compute and this sleeping compute time, and new paradigms might come in the future, might require like really like spending this RL, this reinforcement learning type of reflections, reflection time to kind of a debate before coming to the final answer, and it is very computational, right? Because you're just crunching, multiplying matrices at that time, and then the GPU just goes burr, and then that's actually proportional to how much electricity you just basically waste at that time. It's not a waste, but it's how much electricity you burn. So, and actually, it's you might think of like I'm using my laptop anyway, right? Why is it a problem that I'm running AI workload on my laptop? But actually, it's very important to know if you are running AI workload or not, because if I'm using my GPU on my Mac or some Linux machine that has like RTX 5090 attached to it, so it just electricity consumption might just jump like 100 or 1000x, right? Because it's like I don't know even like uh, what's the electricity. We can look it up the numbers, but they are extremely high. Um, so coming back to the question, so graph rag, how can it be more efficient? Yes, if you flatten, I saw the demo, right, when the graph rag gave an answer really fast, but Code Cloud was taking its time and it was basically burning tokens. If you think in a way like if they gave identical answers, so that's a waste of compute, waste of tokens. That's not great. But even if we were to optimize GraphRack itself, instead of this flat, we are saying there's a flat graphs, um, it could be experimented. To be honest, I haven't done it, but my first instinct was to go with a node and relationship structure like reach a graph, because that could be extended easily in the future. If someone in a company, let's say, if I want to provide a consulting service to a company and they care about a specific relationship that is internal to company, graph code graph rack could be extended to support that. With other structures, I didn't know. I didn't think that they could do. But in terms of efficiency, if we can make it more efficient, I already do. I already use my code graph rack for some type of tasks, and most of the time as an MCP server in a Cloud Code, and it just does less computation because Cloud Code just defaults to grep, which is like inefficient sometimes. But how to optimize code graph rack even further? I don't know. That's a good thing to have. Like maybe if you have any ideas on how could it be done more efficiently, that might be helpful. Maybe some architectural change, orchestrator and the cipher agent, how they interact, or yeah. There's so many ways to go. I don't even know. It's again this project was born maybe a year ago, and it's mature enough, but it's not obviously it's not at the state of that it's the most optimal shape in most optimal shape. Yeah.
Thanks for that. I think Sumaya just has one last question, and then I think we can close off the session.
Sure.
I think I have seen some question about the tools you are using on the chat previously when you were presenting, so I didn't want to miss on that. So, what are the tools you are using currently, and what tools do you suggest for
Yeah.
even beginners who are new to this?
Yeah.
It might be AI, it might be RAG, it might be Graph RAG. So, what tool do you recommend them to use as well?
Sure. For AI tools, obviously there are many AI tools and agents nowadays, but the ones that I prefer are Claude Code, because Anthropic models are best for coding, and most of them are use cases for code, and especially the latest generation, right, models. And the Claude Code is a good harness, and the harness is basically what you put like this whole scaffolding around the foundational model, right? Because you can, Cursor also has Claude Code, but if you compare, I don't know, from my experience, the Claude 4.7 in Cursor versus in Claude Code, like it seems completely different model, which means the harness actually makes a difference. Codex is also nice by OpenAI. For some tasks, when Claude suffers and struggles, I just switch to Codex to see if it can fix it. Sometimes it does, sometimes doesn't, because GPT 5.5 is a bit unpredictable model. It might do some dumb mistakes, but it can also solve very challenging ones. So that kind of as a backup can be used. For general like non-code related AI use, I use Gemini model a lot, uh, especially for, I don't know, open-ended questions, or generating some stories or songs, or just getting an understanding of the high level of some architecture, or just brainstorming is really good. I would just default to Gemini. Um, for I showed like for coding, I use VS Code, but right now I've mostly switched to my own IDE, because I want really fast native performance. Basically, I don't want an IDE. I just want to be in a terminal, and the Croft is actually emulating VS Code in a terminal, as if you are in VS Code, but actually you are in the terminal. So that's what I like to use because of the speed. Um, what other tools? With the graphs, I would say memgraph. Why I chose memgraph is because it's in memory and it's very fast. But to be honest, if you want to play with Cypher, understand, yeah, you can. If you know a bit of SQL, Cypher is like almost given to you. It's like a bit of difference in syntax. Um, but yeah, if you want to understand the graph and so on, there's so much to read about it. But underlying it doesn't matter. I would say Neo4j is also good. Uh, memgraph is good. There's also Helix DB, the new written in Rust, this database. Falker DB. There's so many DBs nowadays that pretty much, I don't know, they do more or less the same thing. It's just, I don't know, some position themselves having a bit of more functionality. Technically, you can write your own vector database. It's not that hard, to be honest. But again, it comes to the question, is it worth it? Is there anything that doesn't satisfy you? Is it writing it is very easy nowadays. What else I use? I don't know, some productivity tools that just help me. I like simple stuff. Like I want, for example, note taking to be cross-platform. If I want to take a note, right? I want to take the same place in my laptop, in my mobile, and so on, and I don't want to think about it. And the one thing I also showed during the demo, I don't type anymore almost. I speak. And the reason I do that, because speech is like 3 times faster, right? I mean, in general, if you are a hacker, maybe you can type fast, but if you are like an ordinary person, probably you speak faster than you type. So I would recommend installing like Whisperflow. It's one of the voice to text programs that you can use. Um, yeah, but all in all, I would say I live in terminal most of the time. This is what I prefer, and agents seems to prefer that. But I rarely switch to IDE if I don't have any other choice.
Okay. Thank you so much, Vitali. Like, I think we are running out of time. Thank you for being here. I think our participant also understand that you are a busy person and you have brought your knowledge, your experience here with us. So thank you so much. I don't know, Sai, if you have anything to say.
This was great. Thanks for spending this time with us. I know
Thanks
you're a
for good
busy,
questions.
you have
Yeah,
a lot of
amazing.
initiatives on uh, going something similar to NSK.ai, much more involved. Uh, yeah,
And I would say like it's a great initiative. I like what you do, guys, and it's a cross-border uh, knowledge sharing is good stuff. And I see lots of countries are joining, which is amazing.
awesome.
Yeah, I think if any also will reach out to you, we want to stay in touch. Probably we're going to host this event next year as well, and in between we may going to have a lot of other events as well. So we really want to have you with us through our
Yeah,
journey.
of
Thank you
course.
so much. Okay, so this will be conclusion of our today's session. Don't forget about posting on social media. Share what you are working on. Share what you are learning about. Tag us on your posts on LinkedIn, X, Instagram, and the winners for today will be announced on Discord. All the materials will be shared on Discord as well. This video will be available on YouTube. The link will be shared on Discord as well. So thank you so much for everyone joining this session. I know it's a long session, but I'm happy that people are interacting, watching, following up. So, yeah, thank you for everyone for joining. This is it. Goodbye. See you
And
all tomorrow.
one
Yeah.
final word, like I think Vitali's open source links will be posted on Discord as well. If you
Mm-hmm.
guys found it useful, like let's promote Vitali as well. Like I don't know what is the equivalent of stars, like since
It's
in
the
your
same
thought.
stars. Yeah, same stars in Goldberg. Yeah.
Cool.
Definitely, we're going to share that. And just as a last word for me, I just encourage everyone to join us tomorrow. Vitali, the invite is also open to you for the next session that we're going to be running. So for us, day 4, we're going to be doing modeling day, right? So looking at data to insight, bias detection, and evaluation. Like Vitali mentioned earlier, these are some of the most crucial aspects of developing some of these agentic systems. And so please join us from 12 p.m. West African time and 2 p.m. East African time for this. So may I hand it back to you?
Okay. Goodbye, everyone. See you all tomorrow. Have a blessed day.